everyone, welcome to the bridge course. Dear children, you might have seen many things in nature. You might have observed some look similar and some look same in shape and size as well. Today we are going to learn about these shapes in detail in our topic congruency and similarity of the figures. Have a look at the screen. After watching this video, you will be able to understand the conditions for the congruency of the polygons, understand the conditions for the similarity of the polygons, and you will be able to differentiate congruent figures from similar figures. Just observe children, these are the games which you wish to play, right? So, you can see a chess game, a ludo and a caroms. Have you ever observed carom coins? Observe carefully, you can see all the coins whether they are white in color or black in color or red, you can see them all same in shape and size as well. Can you recall the name given to such objects? Yes, they are congruent. All the carom coins are congruent. Now, just observe the striker and the black coin here children. Do you think the striker and the carom coin are congruent? No, even though they have circular shape, they are not same in size and shape as well. So, they are not congruent. Now, observe the chessboard children. You can see squares on the chessboard. All the squares of the chessboard are congruent. They have their sides equal and hence they are all congruent. Have you seen the chess pieces? We arrange pawns in the front row. Don't you think these are all same in shape and size as well? Yes, of course, they are all congruent. Now, when the players arrange their pieces on the chessboard, you can observe that the kings on both the sides are congruent and the minister on both the sides are congruent. Similarly, the other pieces on the chessboard can be seen that they are congruent. Now, when you buy a pen set or a crayon set, you might have seen that they are all congruent. Now, when you use the crayons for drawing, you might need few colors more and you might not use few colors at all. So, after using them, do you think they are congruent? No. You can observe here, the used crayons are not congruent. And the currency notes children, you can see all the currency notes with same denomination are always congruent. You can observe the coins on the right side, they are all congruent. They are all same in shape and same in size. Now, observe this bridge children, it is the Howrah bridge. Have you seen the triangular structures on it? You can notice there are many triangular structures on this bridge. Are they all congruent? Observe the triangles that are at the center of the bridge. They are congruent. Now, just have a look at this triangle children. It is triangle ABC. Now, we can write this as with a triangle symbol and the vertices one after the other in order. That is, we write it as triangle ABC. Now, can I write it as triangle BCA? Of course, I can write. I can start from the vertex B and I can take C and A after it. So, I can write it as triangle BCA as well. Now, I can even write it as triangle CAB, that is starting from one vertex and writing the remaining vertices in order. So, when we are considering one triangle, we can write it in any of these manners, but when you are considering two congruent triangles, can you change the order? Is it correct to change the order? Let us see. Now, observe the congruent triangles here. You can see we have two triangles, triangle ABC and triangle PQR. These are the two triangles and given that these two are congruent, that is they are same in shape and same in size. Now, let us observe the corresponding vertices of these triangles, triangle ABC and triangle PQR. You just observe children, the corresponding vertex of A is P, the corresponding vertex of B is Q, and the corresponding vertex to C is R. So, the order of the vertices matters here. We cannot change the order as such here. As it is mentioned that triangle ABC is congruent to triangle PQR, the order of the vertices is important when we compare the triangles. Now, observe these two triangles again. Now, in these two triangles, corresponding side to AB is PQ and corresponding side to BC is QR, and the corresponding side of the third side of the triangle ABC, that is AC, is PR. Corresponding side to AC is PR. Observe these two triangles children again. Let us compare the angles of these two triangles. The corresponding angle of angle A is angle P. Then the corresponding angle of B is angle Q in the triangle PQR. The corresponding angle of C is angle R. Observe these two triangles again. We have seen that these two are congruent, and now just I am moving the triangle PQR a little forward. Observe, yes. After moving it, do you see any difference in its shape or size? No, it is same as before. So, when we move congruent triangles, we do not see any change in their shape or sizes. These two triangles remain congruent now also. Observe children. Now, we will just rotate triangle PQR. Just observe children, look at it, the triangle PQR is being rotated with certain angle. When it is being rotated, do you see any change in its size or shape? You can observe on the screen. After rotating, we do not see any change in its shape or size. So, the two triangles remain congruent even after rotation, just their orientation change, not their congruency. Observe children. Now, let us flip the triangle PQR vertically. You can see its orientation changed, but it is same as before in size and shape. It is congruent to triangle ABC. Now, let us flip the triangle PQR horizontally. You can observe children, the orientation of the triangle PQR has been changed, but you can see that the triangle PQR is still congruent to the triangle ABC. So, flipping of the triangle will not change its congruency. Observe these patterns children. You see these patterns on the wallpapers and on the floor designs. Just have a look at it. These are all made by moving, flipping and rotating the congruent figures. Just observe how they have been designed. Observe children, the congruent figures have been moved to form a pattern, and again this whole thing is being moved to get a beautiful design. You can observe. Yes, it is amazing, right? The congruent figures have been moved to get a beautiful wallpaper. Now, observe this shape children. It is being rotated. Yes, you can observe it is being rotated through 180 degrees, 90 degrees sometimes to get a beautiful pattern. You can observe that. This is how the floor designs are made. Let us learn about the congruent shapes in detail. Observe the line segments on the screen children. You can see two line segments, line segment red in color and green in color. You can see that they look equal in length. Let us try to measure them. Yes, you can see the length of the line segment, which is red in color, is 18.5 centimeter. Now, let us measure the green color line segment. It is also 18.5 centimeters. These two line segments have equal measure. Let us try to place this line segment one over the other. So, you can observe they coincide. This is happening because they have equal measure and they are congruent. When you place congruent things one over the other, they will coincide. Now, let us observe these two angles. You can observe angle ABC and angle XYZ on the screen. The orientation of these angles is not same. You can observe. Let us try to measure these angles. Angle ABC is 45 degrees and angle XYZ is also 45 degrees. So, these two angles have the same measure. Let us try to place these two angles one over the other. Let us see what happens, whether they coincide. Yes, exactly, the two angles coincide. They are equal in measure and hence they are coinciding and they are congruent. Now, observe the triangles which we have considered earlier, triangle ABC and triangle PQR, and we have seen that they are congruent. So, let us try to place one over the other to check whether they are coinciding. Observe children, triangle PQR is being placed on the triangle ABC and these two triangles coincide. So, this is happening because the corresponding sides of these two triangles are equal in measure, that is AB is equal to PQ, BC is equal to its corresponding side QR and AC is equal to PR. Similarly, the corresponding angles of these two triangles are also equal in measure. Angle BAC is equal to angle QPR. You can observe angle ABC is equal to angle PQR. Even the third angles of these triangles are equal in measure. So, we have the corresponding sides equal and also the corresponding angles equal in these two triangles. We say that these two triangles are congruent as they have corresponding sides equal and corresponding angles equal as well. You can observe the symbol for congruency children. We write it as triangle ABC is congruent to triangle PQR. Now, observe these two rectangles. You know very well each angle of a rectangle is 90 degrees. So, the corresponding angles in these two rectangles will be equal. Now, let us try to place one over the other to see whether the corresponding lengths and breadths of these two rectangles are equal. So, let us do that. Yes, they coincide with each other exactly. So, these two rectangles have their corresponding angles equal and their corresponding sides also equal. They are congruent. Hence, we can say children, two polygons are said to be congruent if their corresponding sides as well as corresponding angles are equal in measure. Observe these trophies children. Yes, I know you like to win these trophies in any competition. Have you seen the shape of these trophies? Observe. Yes, they are same in shape. Now, observe the size children. Do you think they are equal in size? No, they are not equal in size. They are just having the same shape. Can you recall the name given to such objects? Yes, you are absolutely right. They are similar objects. For similarity, we refer to the shape of an object irrespective of their size. Now, just have a look at the examples which we have already considered. the coins, the carom coins, the crayons and the currency coins. These are all congruent, we have already discussed. Now, my question is, can we say that these are similar? Think. Yes, similarity refers to the shape of the object. So, you can see all these objects, like all the carom coins are similar, all the crayons here in this picture are same in shape. So, we can say they are similar. Similarity refers only to the shape of the object irrespective of their size. So, all the 10 rupee coins are congruent and similar as well. Now, observe these two figures, children. They are same in shape and they are same in size. So, of course, we will say that they are congruent. Now, we can even say that they are similar. Yes, as they have same shape, we can say that they are similar. Now, just observe the third figure which we have now on the screen. Yes, the third figure is also same in shape with the other two figures, but it is bigger in size. So, when we compare first and third figures, can we say that these two are congruent? No, they have different sizes. We say that first and second figures are congruent, but first and third figures are not congruent. But we say first and second are similar and first and third are also similar as they have same shape. So, we can say that, children, all congruent figures are similar, but all similar figures need not be congruent. Observe Taj Mahal, children. It is a beautiful monument. Now, when you draw a Taj Mahal on a paper, what do you do? Yes, you will be drawing its shape on the paper. Can you imagine that you can draw the Taj Mahal, the whole of the Taj Mahal as it is with its size on a paper? Is it possible? No, we will draw only the shape of Taj Mahal. We will reduce its size so that it fits on the paper. So, our drawing will be similar to the monument Taj Mahal. It is a similar figure. Observe this birds, children. They might not be of the same size, but they look similar. When we draw trees, birds, animals in our notebook, we will just draw similar figures. We take care of their shape and taking care of size might not be possible. When you conduct certain experiments in your laboratory, what do you do, children? And you write notes for that experiment, and you will be drawing the process, the apparatus in your notebook. Will you draw to the same size? No, you will be drawing its shape with reduced size. This is how it looks. Similarly, when we see the world map in our textbooks, we just see the shape of the whole world, not the size. This is the application of similarity. The whole world map is being scaled down to fit in the textbook. The shape will not be altered, but the size will be reduced. So, this is how the bigger objects are being reduced in size, maintaining its similarity to draw and to print in our textbooks. Now, do you think it always happens that only the larger objects, the bigger objects are scaled down and drawn in our textbooks or printed in our textbooks? No, we even see the living things. You can observe the bacteria and the viruses. You know very well, you cannot observe them with your naked eye. To learn about them, you will be scaling up. Virus and the bacteria will be printed on the textbooks to study about them. So, these are the similar objects which are enlarged. Now, coming back to our triangle, children, just observe the triangle ABC. You can see the measures. AB is 2 centimeters, BC is 4 centimeters and AC is 3 centimeters. Now, observe one more triangle, triangle DEF. You can see that the measurements of the sides of the triangle DEF are also given. D is 3 centimeters, EF is 6 centimeters and DF is given as 4.5 centimeters. When you closely observe these two triangles, you can see that they look same in shape, but they have different measurements. Their sides have different measurements. Observe, even the angle A is equal to angle D. Angle B is given as equal in measure to angle E. Angle C is equal to angle F. That is, the corresponding angles in the triangle ABC and triangle DEF are equal in measure, but we see that their sides are different. Let us see, considering their ratio. Let us consider the ratio of the corresponding sides AB and DE, that is AB by DE is 2 by 3. Now, let us take the ratio of the sides BC and EF. We can see that BC by EF, which is equal to 4 by 6, is also 2 by 3. Now, when we consider the ratio of the third sides CA by FD is equal to 3 by 4.5, on simplification we get it as 2 by 3. We observe that the ratio of the corresponding sides in the triangles ABC and DEF are equal. We say that these two triangles are similar, that is, the corresponding angles are equal and the corresponding sides are in the same ratio, and hence these two triangles look similar. Now, observe the rectangles on the screen, children. You have three rectangles. You have rectangle ABCD, where the length of rectangle ABCD is 3 centimeters, AB is 3 centimeters and BC is 2 centimeters. You have the bigger rectangle, length of it is 7.5 centimeters and the breadth LM is 5 centimeters. You can observe the third rectangle, EF is 4 centimeters and FG is given as 5 centimeters. Now, when we observe these rectangles closely, we can see that rectangle ABCD looks similar to rectangle KLMN, but the rectangles ABCD and rectangle EFGH do not look similar. Let us see how the ratio of their corresponding sides is. Now, observe these two rectangles, children, ABCD and EFGH. Let us consider, as you know very well, that each angle of the rectangle is 90 degrees. So, the corresponding angles in these two rectangles are equal. Now, let us have a look at the ratio of their corresponding sides. So, the ratio of the side EF to AB is, EF by AB is 4 by 3, FG by BC is 5 by 2. You can notice that these two ratios are not equal, and that is the reason these two rectangles are not similar. Now, let us consider the two more rectangles which we are saying that they look similar. Now, let us just try to take the ratio of the sides KL and AB. KL by AB is equal to 7.5 by 3, which is simplified to 5 by 2. Now, taking the ratio of their breadths, corresponding sides LM by BC is equal to 5 by 2. So, the ratio of the corresponding sides in these two rectangles are equal. So, they are similar. We can say that two polygons are said to be similar if their corresponding angles are congruent and their corresponding sides are in the same ratio. Now, observe these two rectangles again, children. We have seen that these two are similar as their corresponding sides are in the same ratio. Now, observe this ratio, it is 5 by 2. We take this ratio as K. Here in this case, we have KL by AB is equal to LM by BC is equal to K, and the value of K here in this case is 5 by 2. We call K as the scale factor. Now, here K is 5 by 2, which is greater than 1. Observe, children, as the value of K is greater than 1, we got the rectangle KLMN as an enlarged one compared to the rectangle ABCD. Now, can you think of what will be the size of the second rectangle if the scale factor k is less than 1? Yes, you are absolutely right. If k is less than 1, you will get a reduced rectangle. So, k is a scale factor, and if k is greater than 1, we get enlarged figures. If k is equal to 1, we get congruent figures. If k is less than 1, we get reduced figures. What have we learned? Two polygons are said to be congruent if their corresponding sides as well as corresponding angles are equal in measure. We have learned that two polygons are said to be similar if their corresponding angles are congruent and their corresponding sides are in the same ratio. And we have even seen that all the congruent figures are similar, but all the similar figures need not be congruent. Let us just have a look at the problems to be solved for today, children. So, have a look at the screen, children. We will just try to solve these problems. You can see the first question on the screen. Name any two pairs of congruent objects from your surroundings. Are they similar? Explain. Triangle ABC is similar to triangle DEF. If AB is equal to 3 centimeters, BC is equal to 4 centimeters, AC is equal to 5 centimeters and DE is 6 centimeters. Find the lengths of the sides EF and DF. Children, try to solve these two problems in your notebook and show them to your teacher. So, we have seen, children, two polygons are said to be congruent if their corresponding sides are equal and their corresponding angles are also equal. At the same time, two polygons are said to be similar if their corresponding angles are equal and their corresponding sides are in the same ratio. And we have seen with examples that all congruent figures are similar, but all similar figures need not be congruent. So, that is all for today, children. We will meet again with the next class in our next session. Thank you.